चल, let's start with this thing. Kinematics lecture 14. Write down heading relative motion in 2 dimensions. See, relative motion in 1 dimension was pretty much easy, right? To understand in the frame and all, right? Yes or no, guys?
Yes.
Now let's talk about relative motion in 2 dimensions. First of all, we should understand what exactly is the. We already understood the concept of relative motion, right? In this is I and this is V. Relative motion in 2 dimensions. So we already studied the concept of relative motion in 1 dimension. Now we'll be talking about in 2 different dimensions what exactly is that. Please remember, if suppose there are 2 objects A and B, for 2 objects A and B, if you want to go in the frame of reference of A, then sorry, in the frame of reference of A, that implies with respect to A you are observing the world. In the frame, you are perceiving with respect to object A. Is this clear? So what will be the velocity of B with respect to A? Velocity of B with respect to A will be VB minus VA. Is this clear? Is this clear? Hello guys. ये सब याद है अपन ने? You already discussed this particular thing. In the case of 1D, it was not. It was just plus minus thingy, right? But when we talk about in 2D motion, again यहाँ पे vectors आ जाएंगे, and you have to use I cap, J cap, and all. So when we talk about in the frame of reference of B vector, this will be with respect to B. So VAB will be equals to, what is VBA? Velocity of B with respect to A. What is VAB? Velocity of A with respect to B. Is this clear? Just किसी के भी we are taking in respect with, that should always be subtracted. Can you see with respect to B? So hence B subtracted. So always note this particular thing. When we enter the frame of any object, when we enter the frame of any object, we subtract its velocity for every other, from every other object, from every other object in the system. In the system. Is this clear? So this is the first note. When we enter the frame of any other object, we subtract its velocity from every other object in the system. So if I am entering in the frame of reference of object B, then I'll be perceiving object A, right? So how will be the motion of object A will be there? That's object's velocity minus the frame's velocity in which I am sitting, right? So always remember this 2-3 concepts are there. And there is one more. If we want to come out of any frame, come out of any frame to the ground frame, then guys, are you writing along with me? We will add the velocity of the frame So basically I'm saying like this, suppose if VAB, which is basically VA minus VB, can you see this A's velocity is with respect to ground and this is B's velocity with respect to ground? Yes or no? So if someone wants what is the velocity of A with respect to ground, if they have given the velocity of A with respect to B and they want what is the velocity of A with respect to ground, so can you see over here? I can add the frame's velocity. So ये छोटे-छोटे concepts हैं. We'll use these concepts. It's derived from relative velocity only, so no big deal. Okay, I'll give you one example. For example, suppose I'll give you one example. Suppose there is this platform. Guys, are you able to hear me? Hello? Guys, I can't hear you again. No, I can't hear you. Please, whenever you have to do any message, just give it in the chat. Zoom is, giving this. I don't know what is happening. So no problem. So example over here is, suppose if you have any doubt, just message in the chat. Okay. Yes. No, I can't hear you. So we'll do this thing next time. We'll not conduct the meeting on Zoom. We'll conduct it on WebEx. Is it fine by you? Okay. So anyways, chalo, listen to this lecture at least. If you have any doubt, please type in the. Suppose, guys, this is a platform. Can you see a platform? Now, there is this platform. Let's say this platform is moving towards east with a speed of 4 meters. The platform is moving towards east with a speed of 4 meter per second. Okay, so basically it is moving towards east with a speed of 4 meter per second. This is your east, this is your west, that is north, and this is south. Okay, so suppose there is this guy who is standing on the platform. Now this guy, he starts running towards the north at a speed of, let's say, 3 meter per second. Now the boy on the platform runs at a speed of 3 meter per second with respect to the platform. Always remember this. This is where the problem will start, with respect to platform. So basically, which velocity they have given? They have given this velocity. Okay. With respect to platform, he is moving with 3 meter per second towards north. So the question is to find what is his velocity. What is his velocity with respect to a person on the ground? So if I want to find out the velocity with respect to a person on the ground, so how will you do? What is given in the question? First, you need to identify what is given in the question. Can you see the platform is moving towards east with a speed of 4 meter per second, right? So basically, the velocity of platform is given with respect to ground. Guys, please identify what exactly is given, and that will be your key to solve any problem. Since it is moving towards east, shall I just name this as I cap and this as J cap? Is this fine? Is this fine, guys? I think so. So anyways, for I cap, will it be fine? Now, what about what else is given? Can you see this is the boy on the platform runs at a speed of 3 meter per second with respect to platform. So now the boy is running with respect to platform at a speed of 3 J cap. Are you getting my point? Can you see towards north? So that's why we wrote is that J cap. So from this data, you should be able to gather this data. Once you will be able to gather this data, now you can find out the velocity of boy. with respect to ground. So velocity of boy with respect to ground. Can you see over here by concept of relative motion? By concept of relative motion, can I say this particular thing? That velocity of boy with respect to platform is velocity of boy with respect to ground minus the velocity of platform with respect to ground. No, not 1 meter per second. It's I cap and J cap. Can you see it? Two dimension. It's two dimensional. It's not one dimension. So VBP is equals to VBG minus VPG. So can you see the velocity of boy with respect to ground will be velocity of boy with respect to platform. Sorry. Plus the velocity of platform with respect to ground. Yes or no? So can you see from the platform, if you are coming to ground, hence you are adding the platform's velocity in the formula. So basically that is what is meant by the second concept which we wrote over here. Is this clear? So now this will be VBP will be equals to 3 J cap plus this will be equals to 4 I cap. So what is the velocity of boy with respect to ground? It will be 4 I cap plus 3 J cap. So if someone asks you about, do you remember the platform? The platform was moving like this at 4 meter per second and the boy was moving like this at 3 meter per second. So can you see over here his velocity plus this velocity, they both were added to give you this velocity, which is the velocity of boy with respect to ground. Can you see the triangle being made over here? Do you remember triangle law? किसी को याद है triangle law? What was the triangle law? When two vectors are arranged in head to tail assembly, then the sum of these two vectors will be equals to what? Give the resultant, the closing side of the triangle taken in opposite order. याद होना चाहिए. So this. So can you see the velocity of B with respect to ground is basically this plus this. Is this clear? Guys, please, if you have any doubt, just message है ना. Now, उसके बाद, this is one answer. And what is what if someone asks you what is the speed with which VBG is addition? Yes. So whenever we talk about is addition, how? Okay. So can you see over here VBG? Can you see? This was by the concept of relative velocity, yes or no? I'm not able to write anything now. Can you see this thing was in concept of relative velocity? Velocity of boy with respect to platform will be velocity of boy with respect to ground minus the velocity of platform with respect to ground. This is how we dealt with relative velocity. Yes. So can you see velocity of boy with respect to ground was not known to you. So basically you transferred this to the right hand side and can you see you got this? Oh, got it. तो इतना सारे h की जरूरत नहीं है ऐसे. So anyways, VBG, is this clear? So if someone asks you what is the speed with respect to ground, if a person standing on the ground will observe this guy, then it will be going with a speed of 5 meter per second. Can you say under root of 4 square plus under root of 3 square? Yes or no? Yes or no, guys? So this is how you deal with in two-dimensional motion. Okay? The most, are you writing all this? Whenever you're done writing all this, just drop me a message in the chat. The main key is to gather data from the question. That is the main key. If you can gather the data correct, automatically your answer will be correct. थोड़ा सा read the question and identify the keywords. Can you see with respect to platform? So ये सब keywords हैं. You need to see those keywords and accordingly write the data. Okay. Whenever you're done noting down, guys, just tell me. So done, guys. Are you done noting down? X tan theta into 1 minus x upon 4 x upon r. Guys, I think I found the formula for equation of trajectory. Equation of trajectory in terms of range. So y is equals to x tan theta into 1 minus x upon r. Guys, this is the formula which I'm saying. I'll confirm it some बाद में. But this is the formula I can gather from the internet as of now. I think this is it. जहाँ तक मेरे को याद है यही है. इसको बाहर भेज. इसको बाहर भेज दे. Guys, I think this is the, you know. So anyways, we try to do it with this formula if possible. And tan theta can be written as, guys, what can tan theta be written as? Tan theta can be written as 4h upon r, right? So 4h upon r into 1 minus x by r. So basically this was your y in terms of h and r, right? I told you there will be two terms. I remember the first term, I can't remember the second term. So it's something like this. So anyways, let's try to solve it. 1 minus 3r by 4 upon r से r कट जाएगा. Here also r and r will get cancelled. 4 and 4 will get cancelled. H is equals to 3h into 1 minus 3 by 4s. Yes, guys, this is it. Please note this formula as well. It will be helpful for you someday. Guys, equation of trajectory in terms of the range, horizontal range and the height. So you can use these formulas someday. Guys, is it clear? Only these two formulas. Just note these two formulas down. Nothing else. Equation of trajectory in terms of range and height, maximum height. So you can note these two formulas and that will be your final answer. Anyways, no need to note this down. I was just confirming whether we did what we did was correct or not with the help of this formula. So headache. Motion of a swimmer or boat in a river. Okay. Hello guys. So basically this is motion of a swimmer or a boat in a river. See, it's like that. Suppose whenever you have any, let me draw a river first. Let me draw the river. Yes. Guys, can you see the river of width, whatever width it is? Let's say the width of the river is W or D, whatever you want. So there is a boy or a boat which is on this side of the bank. Okay. Hello. Yes. Sorry, I forgot. So basically now what has been given, they will give in the question like the speed of the river. Yes. So whenever they will give you the speed of the river is basically, so what will be that velocity? That velocity will be 3 meter per second. Suppose the river is flowing in this direction at 3 meter per second. Okay. So the speed of the river is given 3 meter per second. So you can write this thing as velocity of river with respect to ground is how much? 3 I cap. Yes or no? Yes or no, guys? Yes or no? So the speed of the river is 3 meter per second. So velocity of r with respect to ground, river with respect to ground is 3 I cap. This is, see the data. From the data you need to gather these terms. Now they will say the speed of the swimmer or the boat in still water. The speed of the river, guys, they are asking this particular thing, asking, they will give you this data, the speed of the river is this much. The speed of the swimmer of the boat in still water. By what do you mean by still water? If it is still water, that implies the water is at rest. Yes, simple logic. But please remember what is the physical significance of this particular thing. If it is still water, that implies the water is at rest. And if the water is at rest, then can I say in the frame of reference of the water? So basically, if it is in the frame of reference of the water or whatever river it is, yes or no? So this will be basically this thing. If they have given the speed of the swimmer in still water is, let's say 4 meter per second. Can you see this particular thing? Speed of the swimmer in boat is 4 meter per second. That implies they have given the magnitude of velocity of boat with respect to river, and that is equals to 4 meter per second. Is this clear, guys? So from the data, always gather these two information, because these two information will be helpful for you to determine how exactly the object will be moving. Okay. So what are the two things? The two things you need to note is first is the velocity of river with respect to ground, and the second is basically the magnitude of velocity of boy or swimmer with respect to river. This is what you need to note these two data. They are very important in solving any question which is there on river boat problems. Okay. Chaliye, write till here. If you're done writing till here, just drop me a message, then I'll start. Okay. See, I'm telling you how to attempt any numerical on based on this one. What is the concept behind it? So, what individual data means in any question? So let's begin. Everyone done, right? So once you got these two things, now the question, matlab the problem will be either to cross the river. So the first part is basically to cross the river in minimum time. Guys, tell me this particular thing. If I want to cross the river in minimum time, suppose this river is not flowing, guys. है ना? If the river is not flowing, if the river is still water basically. So what should be your direction in such a way that you cross this river in minimum possible time? If the river was at rest, then what would be your direction in such a way that the time taken by you is minimum? How will you be taking the least time when you will be traveling at certain angle? Will you be taking, just tell me this particular thing. A, B, C, D, and this is, let's say, still visible, still water. So tell me which will be the time. What shall be the direction in which you will jump so that you will take minimum time? Just mention whether it's A, B, C, AC or AD in the chat. Perpendicular to the river bank. Pak, say ekdam correct. So if we always remember this particular thing, if I want to cross the river in minimum time, then for minimum time, the swimmer needs to the swimmer needs to it depends on the stream. Yes, it will depend on the stream, but how will he be walking with respect to still water? That is what you said, na? Ground frames, if the river start flowing, then it will be a different thing. But this concept will remain same, na? For minimum time, the swimmer needs to travel perpendicular to the direction of the river speed, if any. That is along AB. AB, yes. So this is what we reach to a common consensus. If the stream is going on the left side, CA is for minimum time. No, because if the stream is going in the left side, then when you jump, you will be further taken away from this point D. So the time taken by you is still minimum in this particular thing only. I told you, in still water, if it's like this, so if this object is having velocity v 4 meter per second, do you remember? This was the velocity in still water, 4 meter per second. Yes or no? So I can decide in which direction I want to jump such that I take at the minimum time. So please also remember this particular thing. When the river is moving, if the river is moving, let's say B R G, and this object says कि I want to cross it in minimum possible time, then always remember his direction of a velocity with respect to river, velocity of a boy or a boat with respect to river should be in a direction perpendicular to river. This is what has been discussed. Can you see in the still water? You derive the concept in still water, right? The still water, that implies in the frame of reference of river, the object shall go in the straight direction. But in actual water, आपने in the frame of reference of river, the boat or the swimmer should travel directly towards the other bank for minimum time. although from ground frame the object will not appear to move along AB. Please remember, ground frame say the object will not be move, appear to move along AB. Ground frame say the object will be moved, moving in the direction of river like this. See, if I draw the velocity triangle for this particular problem, velocity triangle is basically the, this thing. The velocity is the relation between various velocity. So VBR. Do you remember this particular thing? Velocity of boat with respect to river is basically velocity of boat minus velocity of river, and that is basically equals to what? Velocity of boat with respect to ground will be VBR plus VR. Yes or no? So VBR was in this direction. VR is in this direction. Can you see VR is in this direction? The velocity of river is towards left. So hence this will be velocity of buoy with respect to ground. So ground frame say it looks like the swimmer is traveling along this direction and it will reach to a point C in spite of point B. Okay. So this will be the drift, the sidewards drift. So although from ground frame the object will not appear to move along AB, it will move along AC and will drift sidewards. And sidewards की जगह पे can I in the direction of river? Guys, everyone is clear about what exactly is happening to him? So basically from ground frame, if you will observe, the object will be seen along this line. The river will feel like the object is going in a straight line motion, but river can't feel anything, right? Hello. So the ground frame say the object will be moving towards point C, although he will be facing towards B. He'll be just facing directly towards the other bank, and he'll be, what do we? He's trying his best to move in the forward direction without bending, without changing its direction. So the object is trying to move in this direction, whereas the river is trying to push it in this direction. That's why the overall motion of the object is in this direction. Please remember the face of the object will be, can you see this guy? Can you see this? This is how he's swimming. Face is over here. This is his eyes. These are his hairs. In this direction he's facing. But he is drifting along with this direction. So anyways, is this clear, guys? Write down the whole thing, whole analysis, and then once we're done with the analysis, then we'll start with the mathematical form, the mathematical part of it. Guys, whenever you're done, just drop me a message in the chat. Done, guys? Okay. Okay. So basically, this is, the conceptual part of it. Now let's discuss the mathematical part of it. Can you see the angle over here? There is an angle over here, theta. Let's say this angle is theta. So if I say this angle is theta, then will this angle be also theta? If this angle will also be theta, then can you see a triangle ABC? And can you see this velocity triangle? Can you see both these triangles? They are same to same or similar to each other. The velocity triangle and triangle ABC are similar to each other. If they are similar to each other, then their sides will be in the same ratio, right? So can I do this particular thing? Acha, what is given in the question? What will be they giving in the question? They will be giving you this and they will be giving you this. So can you see here, you can relate them with tan theta is equals to VR upon VBR. Yes or no? So VR upon VBR. Yes or no, guys? Perpendicular upon base, VR upon VBR. And here in this triangle also, you can relate it as BC upon AB, right? If I say the drift is X and the width of the river is W, then can I say tan theta is basically equals to, I'll just draw the two triangles again so that I'll don't need to go up and down again. So this is your velocity triangle, this is your VBR, this is your VR, and this is the velocity of boy or boat with respect to ground, whatever it is. And the triangle, I'll make it a little bit smaller so that at least, and this was your triangle ABC. ABC. Can you see VR will be along AB, VBG will be along AC, and VR will be along BC. So AB was basically the width of the river, and BC is basically the drift, which is equals to, let's say, X. So drift is X, width is W. This angle both are thetas. So here tan theta, so I can use the similarity. I can write VR upon VBR will be equals to X upon the width of the river. Can you see this? Yes or no, guys? Can you see this particular thing? So basically this is using similarity. Acha. The time taken to cross the river will be equals to, The time is same for, if you observe from ground frame or if you observe from the reverse frame, doesn't matter. Time taken to cross the river will be basically equals to what? Displacement upon velocity in the direction of displacement. So can you see over here, displacement upon velocity is basically the time, right? So I can write the time as what is the displacement in this direction, in the vertical direction. What is the displacement in the vertical direction, guys? The displacement in the vertical direction is W. And what was the velocity in the vertical direction? VBR. Similarly, what is the displacement in the horizontal direction? It is equals to X. And what is the velocity in this direction? So can you see how the time can be found out easily? Can you see this equation and this equation? They will satisfy each other. Can you see? They are same. VR upon VBR is basically X upon W. So is this clear, guys? How do you find out the time? This is how you find out the time. With this equation, you can find the minimum time. This is the minimum time taken to cross the river. Is this clear? Please write it. Thank you, Gita. And please remember, if you are able to find out this thing, I'll give you, a one question. For example, we'll give you one question based on that. Is this clear, guys? Guys, are you done noting down? I'll give you one question. A boy wishes to cross a river flowing at 3 km/h in minimum possible time. So when I talk about minimum time, so which concept will be using? This one. So find the first time. Please note minimum time. Second, his velocity with respect to a person on the ground. So when I talk about velocity, I need magnitude as well as direction, both. Find this. Shiroja, I'm giving you 2 minutes to solve this problem. How do we know the length of the river? Yes, sorry, my bad. Wait, I'll just give you the length of the river. Length of river is 1 kilometer. Okay. Please remember the length of the river. I'll just write somewhere over here. Length of a river is 1 kilometer. And last part, one more part, third part. Find the sideward drift. Find the distance by which the river drifted him in its direction. Just give me 2 minutes, guys. I'll just come from washroom. Yes, guys. What's the answer? First part. First of all, whenever any word problem is given, draw its diagram. It's very easy to draw. Can you draw a river like that? एक river बना लो ऐसी, fake river, which is flowing with a speed of 3 kilometer per hour. So 3 kmph, and you have a guy who can swim at. This is velocity of river with respect to ground, and this will be equals to 3 I can. And what else? The boy can swim at. The boy can swim at 5 kilometer per hour in still water. Can you see in still water? This is your keyword. Remember this keyword. This will give you. This is with respect to river. Okay. 5 jk. Why 5 jk? Because we know for minimum time we need to cross. We need to. This boy needs to just go in the direction perpendicular to the river flow, right? So this is your velocity of boy with respect to river. This is your velocity of river. So basically the boy will actually go in this direction, right? So it will reach at point C. This point is A, this point is B. So can you see direct problems, word problems can be solved easily. So now we know the time taken will be equals to what? This distance, the width of the river was given 1 kilometer. So the time taken will be what? This 1 kilometer divided by what is the speed in this direction? 5. So 1 divided by 5 km, which is equals to 1 by 5 r. And what is 1 by 5 r? I think it's 12 minutes. What about the sideward drift? The sideward drift will be 9. The second part is to find out. The second part is to find out what is the his velocity. The velocity of boy with respect to ground will be basically VBR plus VR. So you'll do this thing and you'll get 3 I cap plus 5 J cap. So if you got this, Now the magnitude of speed of boy with respect to ground will be equals to under root of 9 plus 25, which is under root of 30 kilometer per. And what is the direction? How will you give the direction? Always remember, if someone asks you direction, so direction, try to give it with respect to river flow. So was this the direction of river flow? So if I take this angle is theta, this angle is also theta, right? So can you see in this case what will be tan theta? Guys, can you tell me what will be the sine theta in this case? Sine theta, no, sorry, tan theta. So tan of theta will be equals to VBR, the perpendicular upon VR. Please remember this theta is with respect to river flow, right? So here in this theta when we calculated, that was different. This theta was with respect to direction perpendicular, right? So tan theta will be equals to this, which will be equals to 5 by 3, I guess. 5 by 3. And hence theta will be tan inverse of 5 by 3 with respect to river. Is this clear? So this is how you give the direction as well. Now the third part is to find out the drift. Drift will be basically equals to what is the velocity in the direction of drift? Velocity is VR multiplied by time. So 3 multiplied by time will be equals to so on attempting to cross the river in minimum time, he'll be drifted sidewards by 600 meters. Any doubt, guys? So this is how you do the problems which are based on relative motion. Is this clear? Is this clear, guys? Yes or no, you can type. So it's okay. Chalo, आज के लिए we'll do this much only, and because of certain technical issues, ज़्यादा interaction तो हुआ नहीं आज. But anyways, next time we'll try to conduct the there's these classes on WebEx, not over here because I think Zoom is giving problem. So that's why next class may we'll do something else as well. So we'll see the upstream downstream thing, and we'll see some more problems which are based on. There is rainman problems, there is riverboat problems in this thing. So we'll see those. Chalo. In the next class we'll be covering the whole thing, relative motion complete, and we'll finish off this chapter, kinematics, completely. Okay, and then we'll start with the Newton's laws of motion in the next lecture, next lecture onwards. Chale guys, thank you very much. Chalo. Thank you.